Now there's a rectangular plot of land that borders a river. So I'm going to draw the plot and the river on the other side. And we want to divide this into three parts. So, and all the three parts border the river. So those are your three parts. And they all border the river. Just for the sake of simplicity, I'm going to take away this squiggly line and yeah, that's the river. Okay. And we are able to use 800 feet of fencing in order to fence this. If you do not fence the side of the river, what should the dimensions of the plot be to help maximize the area? So first of all, since the big question mark over here is what the dimensions are, I'm going to start with giving some names to the dimensions. So let's say that each of these sides that I'm looking at, let's say each of them is called X. So if this side is X, this side will also be X, so will this side, and so will this side. All of these sides are X since they're all sides of a rectangle, so they equal each other. There's one more side that I need to fence. That's this side on top. I'm going to call this side L. Okay? And now, I know that I have 800 feet of fencing to fence this part, this part, this part, this part, and this part. So I'm just going to count all of those parts and write an equation as to what 800 means. So you'll see that there's X 4 times, so that's 4 times X, plus there's L 1 time. L will equal 800, since that's the amount of fencing that I'm given, 800 feet in units. Let's not forget that. Okay, and now I want to be able to find how to maximize the area. So since the area is the other equation in question, now the area of this entire thing is going to be the same as the area of this entire rectangle, and the area of the whole rectangle is just the length times the width. And in this case, the length times the width is L times X. Unfortunately, this is now, we're dealing with two variables and we have two equations. So what we're going to do is we're going to solve them simultaneously. Now in order to do that, first thing I'm going to do is in 4x plus L equals 800, I'm going to solve this equation for L. So to solve this equation for L, I'm going to carry the 4x over, and in order to do that, I'm going to subtract 4x from both sides of the equation. So I get L equals 800 minus 4 times X. Now this is great because what I'm going to do is I'm going to use this and I'm going to substitute it in this equation over here. So my new equation now for the area is area equals L times X, where L is 800 minus 4 times X. Now I can open the parentheses by multiplying these out, distributing the X. So 800 times X is 800X, and negative 4X times X is negative 4X squared. Okay, so this means that the area of the entire rectangular plot is given by an expression that looks like this. Now if this were a function, you'll see that this is a quadratic expression, and so this would be the equation of a parabola. Also, you'll see that the leading coefficient in this case is negative 4, because negative 4 is the coefficient of x squared. In fact, I'll write this better. I'll write this as the area as negative 4x squared plus 800x in the standard form, so you can see that that's the leading coefficient. So this is going to be a parabola that faces downwards. I have no idea where the vertex is. I'm assuming it's somewhere. This picture is for representation purposes only. So since it's a parabola that faces downwards, the maximum will occur at the vertex. So all you need to do is you need to look at this equation of the parabola and be able to find the vertex of the parabola. So now in order to find the vertex of the parabola, let me remind you of the formula. If you have an expression that looks like this, y equals ax squared plus bx plus c, then the vertex is given by negative b over 2a and f of negative b over 2a, where f is nothing but the y is the same as f of x. So So all we need to do is find the x coordinate for now. So we're going to start with just finding negative b over 2a. Negative b over 2a, in this case, well, b is 800, so that's negative 800 over 2 times a is negative 4, so 2 times negative 4. So that's negative 800 over 2 times negative 4 is negative 8. Negative 800 over 8 is just positive 100. So this is nice because you know that the value of x is going to be 100 feet. And to find the value of L, we have an equation for L in terms of x. So we know that L is 800 minus 4 times x. So that will be 800 minus 4 times 100. So that will be 800 minus 400, which is 400 feet. As a bonus, so we have the width is 100 feet and the length is 400 feet. These are the dimensions that you need. And as a bonus, let's also find the maximum area. The maximum area is going to be the length times the width, so or L times x. So that's 100 times 400. So the maximum area that you can hope to enclose is 40,000 square feet with just 800 feet of fencing. So these are the answers that you're looking for.